Right, go. Welcome to my video where we attempt to test the DCDC converter while it's isolated but in situ in the Honda Insight Gen 1. This attempts to emulate what Mudder's done on a bench, essentially, but in the car. So the car doesn't have a 12-volt battery fitted in the engine bay, and it's got a dying IMA battery. So I'm going to still attempt to use the power from that battery for the high voltage feed for the DC. So to start with, if we look at the connections, these are the screw terminals at the rear of DC. So I've taken off the original connections and I've put some different cabling on to my battery. Those are the original connections there. I've also disconnected the high voltage input to the DC here. And then at the other end, I've disconnected all the different plugs that go onto the side of the DC and the one at the top. And as you can see, in the plug here, that would normally plug into this terminal at the back, we've got the snip of the white and green, and I had snipped the black and green, but I've reconnected that. So we've got the terminal that goes to the positive, although it is black, apologies, that connects to where the black and yellow would plug in, and then the negative terminal, which is red, that actually connects on to the plug terminal that would be the blue and white. So following those two cables, we've got from the negative, blue and white, we then go up through a lovely crocodile clip, around my wire, all the way up to the battery negative terminal. And from the negative terminal, we then go down the thicker cable that goes down to the back of the DC upper of the two connections. And then on the positive side, we have our cable from the black and yellow pin that runs up through my crocodile clip setup to the battery positive. And then we've also got a positive cable that goes all the way down here, and it goes into the lower connection on the DC. So I'll just demonstrate the voltage of that, and then we'll move on to the high volt. There we go. So battery voltage is 12.73 volts. And if we check the high voltage from the IMA battery, so while it's off, we got 22.2. If I turn it on, we got 156.7 volts. So turn it off, and then I'm going to connect up the DC high voltage input to the IMA battery, and assuming that the black cable is the negative terminal. It's quite hard to tell because this grey socket doesn't seem to have any indicator on it which is positive and negative. So that's connected. The 12-volt system is all connected. So if we put the multimeter probes into the battery, we should still have our 12.73. Let me get the probes in correctly. 12.73 volts. And then when we flick the high voltage to on, if the DC-DC is working correctly, it should jump to 14.x approximately. So I'll turn that on. And it still stays at 12.73. So frustrating, and it might be my my wiring, but we don't seem to have an increased output. Fluctuating 12.73. So happy to take any comments. I imagine the next step is probably taking the DC-DC converter out, doing the same test on a bench, and then determining if there might be an internal fault. And there we go. Thanks very much for watching.